Alright, I'm back. Time to put the drain plug in. You got two options. You can put sealer on it, you can put Loctite on it. I usually use Loctite. I like it better than sealer. So I use my capillary action Loctite, which is 290. That means it's wicking grade now, new name. People don't know what the hell capillary means, so they know what wicking means. Maybe. Maybe they just think it means wicked. And you put on there like that. Put in here, and it'll seal the case as it goes in. And it'll wick in and seal up anything that's open. I don't use a zip gun on this one. Might have a problem doing that. I do like my hammer though. Okay, and if you want to take a little bit on, put on the outside surface. And see how it just runs around. Soak into anything, any gap that's anywhere, it soaks it around. I'm cheap, so I come back and re-soak it back in. Alright. It'll seal up itself. It'll suck into any orifice and plug it. That's what they call it, capillary or wicking. Alright, there you go. Simple. Time hole plug. Use this one. I leave it loose on purpose. You dumbass, you're supposed to time it before you run it. If you don't, and you lose your plug, that's your own damn fault. I've had that, people do that. So do you time your motor? Oh yeah. Why was the plug loose? Oh yeah, I forgot to. There you go. Okay, you always want to run a file across your nice freshly machined surface here. All the beating and banging, the rod's hitting there, there's a little bit of a lip there, a little bit of mismatch in the machining, you name it. You can hear it when it first started. It's off the high spot. Okay. It also highlights the case mismatch because the dowel pins suck. So you see that's high here. See this one's high here. This one here, pretty even. This one down here looks pretty even. A little bit higher on this side though. This one lines up real nice. A little bit of lip, that's why there's gaskets. There's always 2-3 thou difference. You got clearance in your dowel pins. It's not perfect. Well, you like tight dowel pins, not loose dowel pins. Does a better job of alignment. Okay, all works pretty good. I like that. Okay, now I can put stuff back in here that we're not taking back out again. That'll be this thing. It's your seal. It's its only job, it's crankcase seal. Seals up the cavity between this edge right here, your seal, where it rubs on it. It's also the only part that really needs to be lubricated because it's the only part that contacts anything. Has a little lip on here so it won't rotate. Goes on the crank right there. Boom, drops down. That is the reason why there's a spring in here. It puts tension on the seal. Holds it in there. In 54, they changed the bearing. They no longer use that seal anymore. They figured out they didn't need it no more. But on the early bikes, they figured they needed it. So there you go. Harley likes making changes. Also, I did that wrong. The oil pump gear goes in there first. Then this goes down there. But that's going to have to come back out again because we have to work on the oil pump, which we have not done yet. See how the gear lines up with that shaft through there? Be better if it was over here though, but it sits over there. Where's our shaft at? Here's our shaft. Double keys on the outside, single keys on the inside. Here's our oil pump drive gear right here. This works a lot better when that's not in there. There we go. Take two hands to do that. Alright, that fits right there. And you got your gear. Drops down. And if it's not engaged incorrectly, like if it's over here, it won't work. It has to be engaged correctly. Center's about over here, it looks like. Close enough. So that's how that goes together. So you rotate your crank, turns the gear, see? The rotating crank, see? Alright. Everything lines up good. See how the shaft's nice and free. No dragging. Good. That also slides up and down nice, easy, so that means it's not dragging either. If you have to beat your parts together, there's a problem. Okay, that part worked okay. That's the last part that goes in. Okay, now we got our oil pump over here. Goes on there. The studs have to line up. If the studs don't line up, the pump won't slide on. So you gotta move the studs around until it does. This one appears to fit on it pretty good. You'll make sure the shaft fits through the hole. A little bit of a drag here and there on it, but basically it goes in relatively easily. It does have some drag on it though, so there's some misalignment going on. Might be a little paint on there, or might be a little bit of misalignment. Fits better once I push the pump on and run it through a couple times, so probably a little bit of paint in there. A little bit of blackness right there, you can see it? A little paint. Alright, so that's good. Now I get the gears, and you have to do the same thing with here. These are our gears. Okay, so thin gears are on the inside. That does not go on there, that's not good. There appears to be some paint on there, got to deal with that obviously. Fat gears do not go on this side, see, they don't work. And on this side. Okay, now we got to figure out how much height we have here. That determines how thick the gasket can be. The gear should be above the surface, the thickness of the gasket minus 3 thou. You want 1 to 3 thou clearance bolted in. Right now it looks like it's probably flush, which means we're going to have bad oil pressure. Because the gasket is not flush, gasket is thickness. Alright. See if the scale doesn't catch on anything. That's not good. It's barely hitting on anything. Not really catching the edge, see, it's just kind of going across. It's basically zero clearance. The shaft sticks up a little bit, it hits that. The gear does not. See the difference between the gear and the shaft? It's only a couple thou difference. So basically, whatever gasket thickness you have here, that is how much blow by you're going to have. Not good. Now, if you want to spend a lot of time and effort, you can sand this surface down until you get your clearance knocked down. Now, those gaskets that go up here are usually about 12 to 15 thou thick. That is a lot of bypass. That's also a lot of sanding. So I have to determine how much of that I really want to do. Not much. But I don't like the big clearance either, so that's a problem. So we know we got a problem there. You can try some more gears, see if they're thicker. Good luck. Now this one we got to do the same thing on it. So put the thin gear in there. See how it catches on it? There's a gap in there. Not much, but there is a gap. Now this gasket's usually 10 to 15 thou thick also. 9 to 11 is real common. I do have some old ones that are made by Excel that were 4.5, 5 thou thick. We will be using those on this one. Because it's sticking up a thou or two, a couple thou. Gaskets should give us about 3 thou, 2 to 3 thou clearance, right on the money. This is our pressure gear. This big fat one is our return gear. It can be looser and not matter as much, but it'd be best if it was tighter. So, got what we got. Okay, this other gear, same thing, it hits on it, see? Alright, so this part we can check pretty easy. Okay, first thing I do is gotta get this paint off of here. Somebody got a little carried away painting. I don't know who would do that. No, not around here. No way. I got a paint removing tool. And it goes in there like this, it removes the paint. See? See how that works? You know, my knife's always dull. It's always dull because it's a piece of crap. Not very sharp. Bad metal. But I do abuse it. But it should know I'm going to do that already. Alright, we knocked off most of the paint. Probably enough to work with. If you want to go in here and do a little bit of this down in here, just to be different. Good enough for me. Alright, let's see if this goes on here. It does not want to go on there. It's like it's tight. It's like it doesn't want to go on. There it goes. Little birdie. Notice how I put it on upside down? That way I can turn it. Alright, that needs a little bit more cleaning than that. Alright, that worked pretty good. Still a little gummy in there because it's got paint residue on there. So you take a little scrub pad, run it through there. We're going to have one of those. Some steel wool works too. Here's some coarse steel wool, scrub pad. Fine steel wool, that doesn't work very good on this job. You got green ones, red ones. There you go. I think the green one is coarser than the red, but I'm not sure, I don't remember. I'm going to go with the vintage one because I can get in there better maybe. Maybe not. This is only going to do so much. Probably paint this late at night. Didn't care. Now I'm paying for it. Gotta work. It's still tight. I think there's some black paint I can't see. Yeah, it's kind of black. Can't see it because it's black. Somebody stole my knife. There. Maybe go in here and knock some of that down a little bit. Now you could put a little sandpaper on there too, but I don't like using sandpaper. Tends to do more damage than good a lot of times. It's aggressive. It's for aggressive applications. This is not aggressive application. It's called clean paint. Getting freer. Appears to be the wrong gear too. Look how short it is. Doesn't fit there. How about this one? Well, that one's loose. Yeah, that's what you want. See, nice free spin. Okay, that one's good. This goes on this side over here. We're cleaning the wrong side. See, this one's a little birdie. Not free yet. Don't clean the wrong side. Unless you want to. It needed cleaning anyway, so. I like working over there. Working over here. So you just go like this. Pinching it with the fingers here. Yeah, nice rubbed on surface now. Slides in there real easy now, see? There you go. No more birdie. Spins nice and free. Alright, that's what we're looking for. Perfect. Good as new. Get that one turning free. Not quite as free on this side, but it's pretty free. A little oil on that will never have a problem. Okay, back over on this side. Okay, now we're going to put our gear in here. Make sure it fits. Put your shaft through the hole. Make sure it's on center. Try the other one. Make sure they all go in there and spin freely like this. This is not real world because it's still got looseness in it. But it gives you a pretty good idea if you're going to have a problem or not. See how it rotates in there good. Let's go ahead and put this in here. Quick mock up. Oop, don't rip your gasket off. Take that off before I rip it. I almost ripped it there. Important gasket, don't rip it. Yeah. Okay, so now we got our pump on here. Everything's slid in right to the gasket surface, which means it's good. The shaft still goes a little draggy, but it goes in. The gears turn freely, which is what you want to see. We have to assume the inner ones are also because I didn't put a key in to drive them. Shaft goes all the way into here. So all this looks like it's going to work. The only problem is that this cover here is flush, so the gasket is going to be pretty bad on this surface. And the inner one's probably be pretty good. We have low return volume, which on a knucklehead is a bad thing, because the top end return system needs vacuum to pull the oil out of the top end, and it doesn't drain out, it has to be sucked out. And when you have loose ass volume in here, it doesn't pull the crankcase pressure out of here like it's supposed to. So when the pistons go down, it draws a vacuum. It doesn't draw as much vacuum, you got head pressure behind it, so it makes the more top end have more oiling issues. Not good. So you want to try to get these clearances as tight as you can to make things better. Alright, so I'm not happy without the thickness of that. It's pretty bad actually. So I'll have to figure that out. I'm going to have to go see if I can find my gaskets, because there used to be a whole bunch of them sitting here and they're not here right now. Alright, let me go do some hunting. Go find some gaskets.